SQL is a programming language designed for working with relational databases. It allows you to retrieve, insert, update, and delete data in a structured way. SQL is the foundation for many data analysis tasks, from simple queries to building complex dashboards. It's a versatile tool that can be used to gain insights from large datasets stored in databases. In this presentation, we'll explore the key concepts and features of SQL and how it can be applied to data analytics. SQL is a powerful language for managing and analyzing data stored in relational databases. It allows us to define, access, and manipulate data using structured queries. Relational databases organize data into tables with columns and rows, which SQL is designed to work with. This database diagram on the slide shows the basic structure of a relational database, with tables, columns, and rows. SQL gives us the tools to create, read, update, and delete data stored in these database tables. SQL is a programming language used to manage and manipulate data in databases. It allows you to define the structure of your data through the Data Definition Language, DDL. The DDL lets you create, modify, and delete database objects like tables and their attributes. SQL also provides a data manipulation language, DML, for inserting, updating, deleting, and retrieving data from tables. And the data query language, DQL, allows you to retrieve specific data from tables based on your criteria. SQL is a powerful tool for working with structured data and is widely used across industries. The history of SQL, the structured query language, is an important story in the development of database technology. In the 1970s, early concepts and prototypes for SQL were first developed. In 1974, IBM's System R research project laid the crucial foundation for SQL. SQL then became an NSI standard in 1986, leading to wider adoption and use across the industry. Through the 1990s, SQL was enhanced with object-oriented features to expand its capabilities. Today, SQL continues to evolve and advance, particularly in the area of data analytics. SQL is the standard language for relational databases, defining the core syntax and functionality. MySQL is a popular open-source database known for its performance and ease of use. PostgreSQL is a robust and feature-rich open-source database, emphasizing data integrity and compliance. Microsoft SQL Server is a commercial database system from Microsoft, widely used in enterprise environments. Each of these SQL dialects has its own unique characteristics and strengths, catering to different user needs and preferences. SQL is a language used to interact with databases. It has a specific syntax and set of rules that must be followed. The core components of SQL syntax are keywords, data types, operators, and punctuation. Keywords like select, from, where, and order by define the operations you want to perform. Data types like int, varchar, date, and timestamp specify the kind of data you're working with. Operators like equals, comma, and or and not allow you to make comparisons and logical statements. Punctuation like semicolons and parentheses help structure your SQL queries correctly. The select statement is the foundation of data retrieval in SQL. It allows you to extract specific data from a database table. You can specify which columns you want to retrieve by listing them after the select keyword. The where clause gives you the ability to filter the data based on certain criteria, so you only get the records that match your requirements. For example, you could use a select statement to retrieve the name, email, and phone columns from a customer's table and then filter the results to only show customers located in a specific city. The select statement is a powerful tool for accessing and working with data in a database. The from clause is a fundamental part of a SQL query, as it specifies the table from which you want to retrieve data. You use the table's name to indicate the source of the data you want to work with. In many cases, you'll need to use multiple tables in a single query, often combining them using join operations. Understanding how to properly use the from clause is crucial for constructing effective and efficient SQL queries. The image on the slide shows a hand holding a smartphone with a database icon, illustrating the concept of retrieving data from a database table. The slide provides a clear explanation of the purpose and importance of the from clause in SQL queries. The where clause is a powerful tool for filtering data in a table, allowing us to select only the rows that meet specific criteria. We can use comparison operators like equals, less than, greater than, as well as logical operators like and, or, and not to define our conditions. By applying these conditions, we can retrieve only the most relevant data for our analysis, helping us focus on the information that truly matters. This targeted approach to data retrieval is crucial for enhancing the efficiency and effectiveness of our analysis. The order by clause is a powerful tool for sorting the results of a select query in a specific order. You can sort in ascending ASC or descending desk order, depending on your needs. Sorting by multiple columns allows you to define the priority order for how the data is sorted. The order by clause can handle a variety of data types, including numeric, text, and date values, making it a flexible and versatile feature. Proper use of the order by clause can greatly enhance the readability and usability of your query results. The key aggregation functions we'll cover today are SUM, AVG, count, max, and min. Sum calculates the total or sum of values in a column. This is useful for getting the overall total of a metric like sales or revenue. AVG determines the average or mean value for a column. This helps us understand the typical or central value in a dataset. Count simply counts the number of rows or non-null values in a column. This is a basic but important metric. Max identifies the maximum or largest value in a column. This can highlight the peak or highest performance. And min finds the minimum or smallest value in a column. This can reveal the lowest or poorest performance. These aggregation functions are foundational for analyzing and summarizing data in reports and dashboards. The group by clause is a powerful SQL feature that allows us to group rows with the same values in one or more columns. This grouping is often used in combination with aggregation functions like SUM, AVG, and count to calculate summaries for each group. Grouping data in this way enables deeper data analysis, allowing us to uncover patterns and trends by summarizing the data into meaningful groups. The visual on this slide illustrates how the group by clause can divide data into distinct groups, which are highlighted with different colors and arrows. Understanding how to effectively use the group by clause is an important skill for anyone working with relational databases and performing data analysis. The having clause is used to filter groups of rows created by the group by clause. It allows you to apply conditions to the aggregated results generated by functions like SUM, AVG, or count. The key difference between where and having is that where filters individual rows before grouping, while having filters the groups after aggregation. So, having gives you the ability to refine your results based on the aggregated data, rather than just the individual rows. Joins are a powerful way to combine data from multiple tables in a database. We'll cover 4 main types of joins: inner, left, right, and full outer. Inner join returns only the rows where the join condition is met in both tables. Left join returns all rows from the left table, even if no match exists in the right table. Right join returns all rows from the right table, even if no match exists in the left table. Full outer join returns all rows from both tables, regardless of matching conditions. The inner join is a way to combine data from 2 tables based on a common column or condition. It only includes rows where there is a match between the 2 tables. This is like an intersection of the 2 data sets. We only get the rows that exist in both tables. The inner join is useful when we want to analyze data that is related across multiple tables. For example, we could join a table of customer information with a table of order details to see all the orders placed by each customer. The key is that the join condition must be met in both tables for a row to be included in the final result. The left join is a type of database join that returns all rows from the left table, along with any matching rows from the right table based on the join condition. It ensures that all rows from the left table are included, even if there are no matching rows in the right table. This is useful when you want to see all the data from one table and any related data from another table, without losing any of the information in the left table. The left join includes 3 key elements. All rows from the left table are returned. Matching rows from the right table are included based on the join condition. Any rows in the left table that don't have a match in the right table are also included, with null values for the right table columns. The right join is a type of SQL join that returns all rows from the right table, regardless of whether there is a match in the left table. It includes all the rows from the right table, as well as any matching rows from the left table based on the join condition. Any rows in the right table that don't have a match in the left table will also be included in the result set. This is useful when you want to see all the data from one table, even if there are no matches in the other table. The right join is the opposite of the left join, which returns all rows from the left table instead. The full outer join combines all rows from both tables, regardless of whether there is a match in the join condition. It includes rows that match the join condition, as well as any unique rows that exist in either table. This ensures that no data is lost and provides a comprehensive view of the data from both tables. The Venn diagram on the slide visually represents this. The shaded area covers the entire space of both circles, showing that all rows are included. The three key points highlighted, all rows, matching rows, and unique rows, summarize the main benefits of using a full outer join. This type of join is useful when you want to see all the data, even if there are no direct matches between the tables. Subqueries are a powerful SQL feature that allow you to embed one query within another. They enable you to filter and manipulate data in more complex ways by using the results of an inner query to drive the outer query. For example, you could use a subquery to find all employees who earn more than the average salary in their department, and then perform some other operation on that filtered data. Subqueries open up a world of possibilities for complex data analysis and reporting. They let you build sophisticated queries that would be difficult or impossible to achieve with a single, flat SQL statement. The visual on this slide provides a nice illustration of how a nested SQL query is structured, with the outer and inner queries shown as separate components. Correlated subqueries are a powerful SQL concept where the inner query depends on the outer query for its execution. The inner query references a column or variable from the outer query, so it must be evaluated row by row as the outer query processes each row. This tight coupling between the inner and outer queries allows you to perform complex, nested logic that would be difficult to express in a single SQL statement. Correlated subqueries are commonly used for tasks like finding the latest record for each user, calculating running totals, and performing conditional aggregations. The key thing to remember is that the inner query cannot be evaluated independently. It relies on the context provided by the outer query. Nested subqueries are queries within other queries. They allow you to perform complex operations by using the results of an inner query as input for an outer query. This provides a lot of flexibility and power for filtering and manipulating data. The inner subquery executes first, and its results are then used by the outer query. This can be done over multiple levels, with subqueries nested within other subqueries. This enables very sophisticated data analysis and processing. Nested subqueries are a powerful SQL technique, but they do require careful planning and execution to avoid performance issues. Window functions are a powerful tool for data analysis, providing context and comparisons within a data set. Unlike aggregation functions that collapse data into single values, window functions generate values for each row, preserving the structure of the data. Window functions enable a wide range of analytical queries, allowing you to calculate running totals, rank, percentile, and other metrics to gain deeper insights from your data. These functions are essential for understanding trends, identifying outliers, and uncovering patterns that can inform business decisions. Ranking functions are a powerful tool for understanding the order and sequence of data. They allow you to compare and order rows within a dataset, identifying the relative position of each element. Ranking functions are essential for data analysis, helping you understand the importance or performance of different items. Some common ranking functions include rank, dense_rank, and row_number, each with their own unique characteristics. These functions can provide valuable insights and support decision-making by highlighting the most significant or top-performing elements in your data. Analytical functions are a powerful set of SQL tools that allow you to perform complex calculations and data analysis. They can be divided into three main categories. Cumulative functions calculate running totals, averages, or other measures across a set of rows. Lag/lead functions access values from preceding or following rows, useful for time series analysis. First/last value functions identify the first or last value within a group or window of rows. These functions provide a lot of flexibility and power for data analysis, allowing you to uncover insights that would be difficult to achieve with basic SQL queries. I'll go into more detail on each of these function types in the upcoming slides. Data manipulation is a key part of working with databases and datasets. I'll cover 3 common SQL statements used for data manipulation: insert, update, and delete. The insert statement allows you to add new rows of data into a table. This is useful when you have new information that needs to be recorded in the database. The update statement lets you modify existing data in a table. This is handy when you need to correct or change information that's already in the database. And the delete statement removes rows from a table. This can be used to remove outdated or irrelevant data from the database. The insert statement is a fundamental SQL command used to add new rows of data to an existing table in a database. When using insert, you have the option to explicitly list the columns you want to populate with values, or you can omit the column names and the values will be inserted in the order of the table's columns. It's crucial to ensure that the data types and any constraints defined on the table are respected when inserting new rows. This helps maintain the integrity and consistency of the data. The insert statement is a powerful tool for expanding the data in your database, but it must be used carefully to avoid introducing errors or violating data rules. The update statement is a powerful SQL command that allows you to modify existing data in a database table. It gives you the ability to change the values of specific columns in one or more rows. To use update, you need to specify the table you want to update, the columns you want to change, and the new values you want to assign. The where clause is crucial. It lets you target the specific rows you want to update based on certain conditions. This allows you to make changes selectively rather than updating the entire table. The column update section is where you actually define the changes you want to make, listing the columns and their new values. Understanding how to properly construct an update statement is an essential SQL skill for any data professional. The delete statement is used to remove rows from a database table. To delete rows, you specify the criteria in the where clause. This allows you to target the specific rows you want to remove. It's critical to carefully confirm the deletion criteria before executing the delete statement. Deleting the wrong rows can result in unintended data loss, which can be difficult to recover from. Always double-check your delete statement to ensure you're only removing the intended rows. Data integrity is extremely important. Transactions are a fundamental concept in database management, ensuring that a series of operations are treated as a single, atomic unit. They guarantee data consistency by making sure that either all operations succeed or none are applied, preserving data integrity. Transactions provide isolation, preventing interference from other operations and ensuring data accuracy. Once a transaction is committed, the changes are permanent and durable, even in the event of system failures. The key properties of transactions are atomicity, consistency, isolation, and durability, often referred to as the ACID principles. Transactions are critical for maintaining data integrity and reliability in database applications. The ACID properties are the fundamental principles that ensure the reliability and integrity of database transactions. Atomicity means that all operations within a transaction are treated as a single unit. They either all succeed or none are executed. Consistency ensures that transactions transition the database from one valid state to another, preserving data integrity. Isolation allows transactions to run independently, preventing interference between concurrent operations. Durability guarantees that once a transaction is committed, the changes are permanently stored, even in the event of system failures. These 4 properties, atomicity, consistency, isolation, and durability, are critical for maintaining the reliability and trustworthiness of database systems. Transactions are a way to group multiple SQL statements together as a single unit of work. Begin starts a transaction, allowing you to make changes that can be committed or rolled back as a group. Commit saves the changes made within the transaction, making them permanent. Rollback undoes any changes made within the transaction, reverting everything back to the state before the transaction started. Transactions are useful for ensuring data integrity and consistency, especially when making complex changes to the database. This slide introduces the 3 main categories of data types: numeric, text, and date, time. Numeric types are used to represent numbers, including integers and decimals. These are essential for quantities, measurements, and calculations. Text types store textual data like strings of characters. These are useful for names, addresses, descriptions, and other text-based information. Date and time types represent dates and times. These are crucial for tracking events, scheduling, and analyzing time-related data. The icons on the slide visually represent these different data type categories in a clear and organized way. I'll expand on each of these data type categories in more detail in the next few slides. Numeric types are fundamental data types used to represent different kinds of numbers in programming and databases. Int is used for whole numbers without decimal points, great for storing quantities, IDs, and other integer values. Decimal is a precise decimal type, ideal for financial calculations or measurements that require high accuracy. Float is an approximate decimal type, suitable for scientific or engineering data, where some imprecision is acceptable. Double precision is an even more precise decimal type that can handle larger and more complex numbers, often used for advanced calculations. The choice of numeric type depends on the specific needs of the data and application. Int for integers, decimal for finance, float for science, and double precision for advanced math. Varchar is used for variable length text fields like names, addresses, and descriptions. Char is used for fixed length fields with a predefined length, like postal codes or abbreviations. Text is used for storing large amounts of text data, such as blog posts, articles, or long descriptions. Enum defines a limited set of allowed values for a field, useful for drop-down lists or fields with restricted choices. These different text types allow you to store and manage text data efficiently in your database, depending on the specific needs of your application. Dates are useful for storing information like birthdays, anniversaries, or event dates. Times are useful for storing timestamps, time intervals, or scheduling information. Timestamps combine date and time into a single value, helpful for tracking events and timestamps. Intervals represent a duration of time, useful for calculating time differences or elapsed periods. These date and time types provide flexible ways to work with temporal data in your applications. Null values represent missing or unknown data in a dataset. Null is not the same as zero or an empty string. It indicates the complete absence of any value. Null values can impact data analysis, as they require special handling techniques when performing calculations or comparisons. It's important to understand how null values are represented and treated in your data in order to avoid skewing your analysis. Null values can be a common issue when working with data, as they represent missing or unknown information. The is null operator is a simple way to identify rows where a value is missing. This can be useful for finding and addressing gaps in your data. The coalesce function allows you to replace null values with a specified default value. This can be helpful for ensuring your data is complete and consistent. The nvl function serves a similar purpose to coalesce, providing a way to substitute a default value for null. Using a case statement gives you more flexibility to handle null values, as you can specify different actions depending on whether a value is null or not. Understanding how to effectively manage null values is an important skill for any data professional, as it helps ensure the integrity and reliability of your data. Functions are an important part of any programming language, allowing you to encapsulate and reuse code. We'll be covering three main types of functions today: string functions, date functions, and mathematical functions. String functions let you manipulate and process text data, things like extracting substrings, concatenating strings, and converting between uppercase and lowercase. Date functions allow you to work with dates and times, performing calculations, formatting dates, and extracting components like the day or month. Mathematical functions give you the ability to perform numerical operations, rounding numbers, finding absolute values, and even trig functions like sine and cosine. These different function types provide a lot of powerful capabilities that you can leverage in your code. String functions are a powerful set of tools for manipulating and working with text data. Upper and lower allow you to convert text to all uppercase or all lowercase. Substring and length let you extract specific parts of a string or get the total length. Replace and trim enable you to substitute characters or remove leading/trailing spaces. Concat and like can be used to combine strings or perform pattern matching on text. These functions provide a lot of flexibility for cleaning, formatting, and analyzing textual information. The slide covers some common date functions in SQL. Current_date retrieves the current date. Current_time retrieves the current time. Date_part extracts specific parts of a date, like year, month, or day. Date_trunc truncates a date to a specific time unit, like a year or month. These functions are very useful for working with dates and times in your SQL queries and data processing. I'll briefly explain how each one works and give some example use cases. Mathematical functions are important tools in data analysis and calculations. We'll cover 4 key functions today: ABS, round, ceil/floor, and power/sqrt. ABS returns the absolute value of a number, always giving a non-negative result. Round allows us to round numbers to a specified decimal place, rounding up, down, or to the nearest integer. Ceil and floor return the smallest integer greater than or equal to a number, or the largest integer less than or equal to a number, respectively. Power calculates the result of a number raised to a given power, while sqrt determines the square root of a number. These functions provide precise control over numerical values and are essential for many mathematical and scientific applications. Missing data is a common issue that needs to be addressed before analysis. There are a few common approaches to handle missing values. Replace with a default value, e.g. 0, average, etc. Remove the rows with missing data entirely. Impute the missing values based on patterns in the rest of the data. Duplicate data entries can also skew analysis results. We can use SQL's distinct keyword to identify and remove duplicate rows based on specific columns. This helps ensure we're only analyzing unique data points. The slide introduces the topic of handling missing data in data analysis. It outlines 3 main approaches: replacement, deletion, and imputation. Replacement involves filling in missing values with a default value like 0 or a specific string. Deletion involves removing rows with missing data if the missing data is not critical to the analysis. Imputation estimates missing values based on patterns in the existing data, using techniques like mean or median imputation. The image on the slide visually represents missing data in a data table, highlighted in red. This provides a clear visual context for the techniques being discussed. The distinct keyword is a powerful tool for removing duplicate rows from your data. It looks at the specified columns and returns only the unique values, eliminating any duplicates. The group by clause is another great way to identify and remove duplicates. By grouping rows with the same values together, you can then use aggregation functions like count or sum to find and remove duplicates. Both distinct and group by are essential techniques for data cleansing and ensuring the integrity of your data. They allow you to quickly and easily remove unwanted duplicate information. Understanding how to effectively use these SQL features will make your data analysis and reporting much more accurate and reliable. Data transformation is a key part of data processing and analysis. We'll cover 4 main types of data transformation. Conversion, changing data types like converting text to dates or numbers. Calculation, creating new columns based on existing data. Aggregation, combining multiple rows into a single summary row. Filtering, selecting specific rows based on conditions to remove irrelevant data. These transformations allow us to prepare the data for further analysis and reporting. We'll go through examples of each type of transformation in the upcoming slides. Clustered indexes determine the physical order of data in a table. This means the data is stored in the order of the clustered index. Clustered indexes can improve query performance for queries that match the index order. Non-clustered indexes point to the actual data location, rather than storing the data in index order. Non-clustered indexes are useful for queries that don't match the clustered index order. They provide a way to quickly find the data, even if it's not stored in the order you need. Clustered indexes define the physical order of data rows in a table, storing them in the order of the index key. Each table can have only one clustered index, which is usually based on a unique key column. This ensures a single physical ordering for the data. Clustered indexes optimize queries that involve searching or sorting data based on the index key, significantly improving performance. Non-clustered indexes create a separate data structure that points to the actual data in the table. This index acts like a directory, providing a quick lookup to locate the data you're searching for. Tables can have multiple non-clustered indexes, each based on different columns. This allows for efficient access to data based on various search criteria. Non-clustered indexes improve query performance by enabling faster access to data. They provide a logical ordering that allows for quick searches without affecting the physical storage order of the data. Indexes are a powerful way to speed up queries by allowing the database to quickly locate the data you need. We should create indexes on the columns that are frequently used in queries to improve performance. Queries can be optimized by avoiding unnecessary operations and using the appropriate join types. Complex queries can often be rewritten in a more efficient way to improve their performance. Caching frequently accessed data in memory can reduce disk access and help retrieve data faster, improving overall responsiveness. Normalizing the data by organizing it logically can reduce data redundancy and improve efficiency. Normalization minimizes data duplication and ensures data consistency across the system. The query execution plan is a crucial tool that outlines how the database will execute a SQL query. It's created by the Database Optimizer, which determines the most efficient way to retrieve the requested data. The plan displays the sequence of operations, such as table scans, joins, and filtering, that the database will perform. Analyzing the execution plan helps identify performance bottlenecks, allowing developers to optimize the query for better performance. Understanding and optimizing query execution plans is a crucial skill for developers working with databases. Indexes are a crucial database feature that help quickly locate and retrieve data. They work by creating a sorted data structure that points to the actual data, allowing for faster lookups. Indexes can dramatically improve the performance of queries, especially on large data sets. Proper indexing is essential to ensure your application's queries run efficiently and don't bog down the database. The right indexes can cut query execution times significantly, providing a great performance boost. It's important to carefully choose which columns to index based on your application's most common queries. Indexing can be complex, so it's worth investing time to understand best practices and monitor index usage. Effective naming conventions are crucial for SQL code readability and maintainability. Choose descriptive names for tables and columns that clearly convey their purpose. Redundant data can lead to inefficiencies and data integrity issues. Design your tables efficiently, leveraging relationships to minimize duplication. Complex SQL queries can be challenging to understand. Use comments to explain the logic behind your queries, making them easier for others to follow and maintain. Thorough testing is essential to ensure the accuracy and reliability of your SQL code. Execute queries with a variety of datasets to identify and address potential issues. SQL is a powerful tool that forms the foundation for data analysis and management. It has diverse applications, from simple data retrieval to complex data transformations and reporting. As an analyst, it's important to continuously learn and explore SQL's advanced features to unlock its full potential. Keep expanding your SQL knowledge to become more efficient and effective in working with data. SQL is a powerful language that allows us to extract valuable insights from databases. It's an essential skill for data analysts and data scientists. Maintaining data integrity is crucial. Transactions and ACID properties help ensure our data is consistent and reliable. To optimize performance, we can leverage techniques like indexing, query planning, and data cleaning. These help make our SQL queries more efficient. SQL is constantly evolving, so it's important to stay up to date on new features and best practices. Continuous learning is key.